Microscopic Studies. Pasha is a medical microbiologist studying the growth rate of Ebola. After recording the growth in several different Ebola samples using a microscope, Pasha must use this equation to determine the rate. So, let us help Pasha solve this equation. So, here we are with our equation. Now, when solving equations with decimals, we are going to use the same process to get the variable by itself. And you may use a calculator to solve these problems. So, here we are with our equation. So let's rewrite it. 2.1n plus 3.1 is equal to 2.85n plus 2.5. So let us first get n by itself. So in order to start getting n by itself, we're going to need to subtract 2.1n to both sides. So we added the 0 right there just as a placeholder. So this cancels out and becomes 0. And now we're left with 3.1 on one side. Now, let us do this subtraction problem. 5 minus 0 is 5. 8 minus 1 is 7. And 2 minus 2 is 0. So, we have 0.75n plus 2.5. So now the next step will be to get n by itself. So let us subtract 2.5 to both sides. So this becomes 0. And then the right hand side has 0.75n. Now the left hand side, 3.1 minus 2.5. So we need to borrow from the 3. So this becomes a 2. We change it, put the 1 over in the tens place. So now we have 11. So we have 11 minus 5, which is 6. Bring down the decimal. 2 minus 2 is 0. So now we are left with this part to solve. Like before, we're just going to divide. So here we are. So we have n by itself because 0.75 divided by 0.75 just becomes n, or 1n. Now we have 0.6 divided by 0.75. So let's just get up our calculator here and do this real quick. So we have 0.6 divided by 0.75, which is equal to 0.8. So we will just write 0.8. And this is our final solution. So let's look at one more example. While looking through a microscope at a sample of a patient's blood, Quant has determined that a portion of the patient's blood looks like half moons. Quant realizes that this means the patient most likely has sickle cell anemia. Normal blood looks like full circles or donuts. Next, Quant will determine the gene that caused the blood cell mutation and compute the frequency of blood transfusions that the patient will need. Help Quant with the process by solving this equation. So, here we are with this equation. Now you will see that on the left-hand side, we will need to distribute because we have a parentheses and with a number in front of it. So this will be our first step, and then we can start solving like we've done in the past. So let's distribute the 2. So 2 times 4.95, which we can either do with a calculator or in off to the side. But let's just do it like this. So we get 9.9. So we got 9.9x. Now 2 times -2 is equal to -4, which is equal to 3.5x plus 4. So let us now get x by itself. So to start doing that, we will need to subtract 3.5 to both sides. So we get 0 here, plus 4 on that side. So this crosses out, right, as we have 0. Now we have -4, and then lost down to do the subtraction problem. 9 minus 5 is 4. We can just bring down the x, bring the decimal. Now 9 minus 3 is 6. So now we need to get x by itself. So the next step will be to add 4 to both sides. So we're left with 0 because -4 plus 4 is 0. 4 plus 4 is 8. So now we have 6.4x plus 0, or you don't even have to write the 0 anymore. Now, this is equal to 8. So to get x by itself, we will need to divide by 6.4 to both sides. So 6.4 divided by 6.4 is just x. 6.4 divided by 6.4 is 1. So we don't even need to put the 1 there. Now we have 8 divided by 6.4, which is equal to 1.25. This is our solution. So remember, when solving equations with decimals, use the same process that you're familiar with. However, you may use a calculator to speed up the calculations.